We're going to go over how to implement PTP inside of a workload domain on NSX. The previous videos that I've done have included setting up NSX, troubleshooting NSX, and enabling multicast in there. So one of the critical things for a enterprise environment, especially if you have a lot of out-of-band work, when you're looking at DevOps, probably the dev portion would be a lot of out-of-band for ensuring security. So, looking into how to get precision time into an out of band network where you do not have NTP pools to rely on. You may not be able to pass through your NTP or PTP server down into workload. That's what really inspired this video. So, one of the first things that you need to have is an NTP or PTP server on your management domain. So if you're using NTP, ensuring that all of your servers can connect over to an NTP source. If you're using PTP, making sure that the ESXi hosts are able to identify the PTP signal. If you're using multicast, make sure they can join the group. If they're using unicast, directed unicast, ensure that they are stood up in a way where they can receive the signal from the PTP server. So we're focusing heavily on PTP on this one. What you'll do is if you're using NTP, enable your NTP, make sure it's set up to the correct server. If you're using PTP, make sure that it is enabled and it is set up to the correct environment. So for us, the VM kernel port that we need to ensure that we're viewing the PTP correctly is listed right here. Like I said, if you're using directed unicast with your PTP, then you would want to have it directed towards that IP address. So once your PTP is set up or your NTP is set up, then you can go ahead and go into the VMs. You can edit your settings, add a new device, and we can go into the precision clock. And we can tell it host system time PTP. So we will add a precision clock with PTP in there. So once that's done, we can go ahead and go over to our VM that has that PTP device. We can cat out the PTP device name, and you'll see PTP underscore VMware. Now this is only going to work on a newer kernel, so the 5.11 kernel. I could not use Ubuntu server, it's running a 5.4 kernel. With VMware tools on 5.11, you'll definitely be able to get the PTP VMware driver up and running. It is included in the kernel, it's ready and it's good to go. So once that's done, you configure Crony. For Crony, we can go ahead and look inside of the Crony configuration. And inside of here, you'll see that I've removed all of the pool, and now we just have the reference clock, the physical PTP hardware clock at dev PTP 0. And so that is really the only change I needed to make there. And then we can look at the sources, and we will see that that physical hardware clock 0 is at a stratum 0, and our drift is at 32 nanoseconds. So we are really good to go here. We are very close. This system has no internet connectivity. You can see there's nothing going on there for internet. We are within a tier 0 that does not have any uplinks out. It has multicast enabled. So then we set up our PTP server, which when we look at our configuration file for PTP. Now you can do this with your PTP for Linux, any of your files to configure PTP should rely on the hardware clock, or you can figure out how to get them to view that hardware clock. But for this particular system, I've got it reaching out on domain 1 through multicast. It is the master. And we have enabled, went ahead and turned on PTP. So this is PTP daemon 2. PTP D2, and it is up and running on the network. Inside of our Windows box, I went ahead and added domain time 2 so that we could get a closer look at drift data. Inside of our drift data here, you can see this is where I had migrated it between an online network and an offline network. So out of band, in band, and actually this is in band, out of band, or pardon me, out of band, in band, out of band. So you can see what happens when I moved it off the network. But our drift is 2.8 microseconds here. That's a fantastic level of drift. Inside of this environment, usually when you're doing some level of scientific work, you're looking at within 40, 50. Having it down below 10 is magnificent. So this is very well done. I would say by VMware of getting the PTP Stratum 0 clock able to pass over into a workload and be able to operate at this level of precision. So the capability here will allow you to not have to fudge a clock. That's a big one. You're going to be passing through your actual time source, which should be registering above stratum 3. So a 0, 1, 2 at your physical level, reaching down, hitting your ESXi host. Your ESXi host is then able to create that precision clock. Once that precision clock is enabled and attached to your time server, you can go ahead and set your time server up inside of that domain, the workload domain, and enable a PTP server there. Now, the reason why I recommend going with a time server in order to present it over to your workload domain is that precision time is meant to be a local protocol. And if you were to try to stretch it around all of your ESXi hosts and then down into devices inside of your VMs, that should work. But to verify that everything is set up with a single point to investigate, or multiple points to investigate, your grandmaster master on PTP is the ideal method of setting it up, making sure that everything is on the same domain and operating in the same manner as it would in a physical network. That definitely adds a bit more fidelity to the PTP environment, especially when you're down to these, 2.8 microsecond deltas when you're doing some serious work inside of here. This is also, I may have mentioned before, without any latency sensitivity involved in the VM. So if we were to enable latency sensitivity, hold off the RAM specific to those VMs, reserve it for them, we may end up seeing that 2.8 drop further. But this is certainly a fantastic method to get your time over into out of band disconnected environments.